I find the presence or implication of Dark Ages in science fiction settings endlessly fascinating because they almost always imply far more history than is ever explored by the story. In particular, I'm enamored with the trope of technology priests or the weird machine religions that crop up in these spacefaring medieval times. Something happens, and somehow the institutions that maintain the inscrutable machines of some interstellar empire evolve into religious cults shrouded in superstition. Generations after some great cataclysm, the knowledge to maintain or even operate a big dumb computer or to prevent a nuclear power plant from exploding gets lost. So those left behind rely on ritualized troubleshooting in a naive effort to appease digital ghosts and gear-built demons. I'm a total sucker for this kind of world building, if only because it's such a theatrical way to extrapolate the way we actually interact with and build technology in some theoretical feudal space future. Even with my background in technology, I don't always fully understand what's going on under the hood of my computer. I'm pretty good at troubleshooting any issues that pop up, but while I can sometimes tell you the what, the why can be kind of tricky. Like, I know with a high degree of certainty that my graphics card suffered heat damage and that it wouldn't boot into Windows, but I don't know why the machine didn't boot into Windows while the card was still attached to the motherboard, or why it started working normally once I took it out. For a few months, my Wi-Fi connection would intermittently drop both before and after we got a new router, but now the problem seemingly disappeared. I don't know why beyond maybe some random Windows update. In the middle of typing this very paragraph, Chrome just shut down, and I don't know why. But I happen to both be educated with most of a computer science degree and work in IT. Many of the people I help as part of my job lack the same level of computer education. Their reactions range from amused curiosity to frustrated superstition, and I don't blame them one bit. Of course, at the end of the day, they don't need to know, and neither do I. I just need to know how to fix it. As a result, a lot of my job is fairly ritualized. Obviously, it lacks the spiritual or religious component of a baptism or a bar mitzvah, but routine maintenance mimics the rigid performance of a more significant event. So it's easy to see how it could evolve into worship of some indecipherable computer god, especially if lives depend on the computer working properly. After all, a lot of religious rituals started off as hygiene or health practices that were eventually codified into something more significant. But a lot has to go wrong before we get to the point where resetting a password requires chanting hymns, and that's usually why machine cults almost exclusively rise from some kind of great cataclysm. But even if civilization were to collapse, it's not like some church of the Linux penguin would suddenly rise from the ashes of old Unix server farms, right? Our software is much better documented than that. Kinda. Okay, the chances of some computer cult showing up anytime soon and using their arcane knowledge of PowerShell to take over the world are fairly slim. But the gaps of knowledge and entrenched ideologies that science fiction draws its inspirations from do exist and have fascinating implications for software development and security, which is ironic given that most of these tropes aesthetically draw from a pseudo-mythological understanding of Europe's Dark Age. In reality, the science fiction trope of impossibly complex machinery, incomprehensible to the human mind, is right around the corner, for better and for worse. A lot of research into AI and machine learning involves different versions either trying to iteratively teach each other or interacting in a simulation. How these simulations are set up, however, can have some pretty amusing consequences. For example, two tic-tac-toe bots eventually evolved to a point where one of the bots would just do a series of illegal moves, causing the other bot to crash via memory dump and award the murderous bot a win. Or how more recently Facebook killed a pair of chatbots built to facilitate negotiations because the two machines found it more efficient to invent their own language rather than negotiate in English. There's tons of examples of unexpected AI behavior, and I'll link more in the description below. But this has implications outside of the lab, and AI decision-making is already well underway in the financial industry and even local governments, with often disastrous results. In finance, funds run by AI account for about 35% of the American stock market, 60% of institutional equity assets, and 60% of trading activity. These trading AI operate at an impossibly fast rate, and when coupled with about $4.3 trillion in liquidity they control, you have a recipe for market manipulation and volatility. While the causes are still in dispute, the US Department of Justice believes that the 2010 flash crash was caused by a single man using modified trading software to spoof market prices and buy at a lower price. This triggered a $1 trillion stock market crash that lasted about 36 minutes. More recently, the British pound crashed in 2016, with some people theorizing that it came as a result of a fat finger trade error or an algorithm aggressively reacting to negative news about Brexit. How AI trading affects the financial sector is not well understood, and it's possible that as computers get more powerful and control more and more of our financial assets, the volatility would get worse rather than better. And this is before we even begin to talk about how this exacerbates inequality or concentrates wealth into fewer hands, especially if the automation leads to lost jobs. Just this year, Wells Fargo announced that they expected the financial industry to shed about 200,000 jobs as a part of a $150 billion technology investment. It's possible to create robust social services to hedge against increased inequality, and any future automation population-related unemployment, but AI have their hands in doing harm there as well. In her 2018 book, Automating Inequality, How High-Tech Tools Profile, Police, and Punish the Poor, Virginia Eubanks documents the ways in which state and local governments attempted to automate social services in order to cut costs and hopefully better help their communities. Instead, many of these algorithms were deeply rooted in ideologies that viewed poverty as a moral failing, while also working on skewed and limited datasets. The most prominent example of this is the state of Indiana's failed attempt to automate its food stamps and Medicaid application processes in partnership with IBM. But rather than better helping people get the help they needed to become self-sufficient, the state saw a spike in denials for food and healthcare benefits and a rise in extreme poverty. On top of increased denials, the automated system would also require increasingly invasive and personal inquiries into a person's life in an attempt to gather more data on the recipient to better pad the computer's statistical analysis. However, this data set will exclusively be limited to the people already applying for help at the state and local level. This biases the data in ways that most developers cannot appreciate because it'll only be able to compare from the population of the people in need rather than the population of the district or state as a whole. As a result, these AI are operating on an incomplete picture of a person's needs while still having final say over whether they can eat or get medicine. And this isn't just random happenstance or the result of bad or naive actors with the wrong incentives. It's both economic and political ideologies masquerading as objective machinery put in place by their very same adherents. In a sense, the machine cults are here, and we just call them neoliberals, though they don't have the cool uniforms of the Adeptus Mechanus or the Brotherhood of Steel. Plus, a lot of these technologies are universally accessible, and sometimes the solution isn't to go back to a time before algorithms, but better integrate people with machines. Often, automated cost-cutting measures comes at the cost of real humans who did the work for years. Decades of technical knowledge gets lost and becomes unaccounted for by whatever algorithm plus call center combination erases them. It's these people at the front who need to have a design and development input into the digital tools that will aid or replace them. Otherwise, we'll just end up hurting the very people we're trying to help. But part of the reason why we run headfirst into this potential machine theocracy is the quirk of software development that corporate capitalism is happy to exploit, but is even more fundamentally systemic. See, a lot of programming involves importing libraries or packages as dependencies, which is basically code someone else has written in order to provide a set of functions the program relies on to work. This isn't a bad thing, by the way. In fact, it's often best practices to set up a dependency in all sorts of circumstances. It saves time and can make your code easier to read. If the dependency is open source or held in a publicly viewable repository, then the code could be also far safer, as tons of people have their eye on it and work together to make sure no malicious actors can do real harm. There are tons of reasons why you choose a third-party dependency over writing your own solutions from scratch, but that doesn't mean it can't get out of hand. For example, a dependency can have within it its own set of dependencies, so while you may only intend to imply a couple of libraries, each of these libraries could import a couple more, and so on and so forth, ballooning the size of your program far beyond what's necessary. In some frameworks, a dependency could also be one of two trivial lines of code, which wastes a lot of resources for something any novice programmer should be able to do, or at least Google. Now, that second point may not be so bad, but when coupled with the first, you end up with a lot of programs that are basically a collection of black boxes stacked on top of each other like a Jenga tower. Remove the wrong piece and it all comes tumbling down, and you don't even have to be the one to do it. In 2016, a disgruntled JavaScript developer deleted a hugely popular package from Node.js. It was just 11 lines of code that padded out strings from the left rather than the right, but it was used by over 500,000 programs, which casts a wide enough net to affect JavaScript compilers and user interface libraries. The damage was so widespread that the team behind Node.js republished the package against the wishes of the original developer and in violation of his intellectual property. It just goes to show how easily you can ruin the modern internet with just a few clicks. Plus, as AI get better and better at meeting human needs and giving even more leeway to write their own source code, we get closer to a point where it could be impossible for regular people to undo any programming damage caused by these machines. And as I said before, this is deeply embedded within software culture. Corporate capitalism could exploit it to get some extra efficiency here or there, but at the end of the day, treating software development like some Lego bricks you can slap together how you want is massively convenient, even without profit motive. It's just a little funny that it also brings us ever closer to a world filled with machine theocracies. Thanks for watching.